This podcast is about how ions form and how you can use the periodic table to predict them. So most elements exist in nature as in compounds so that they are bonded. And atoms bond because they want to gain and lose and share electrons so that they have the same number of electrons as the noble gases have because they're really stable. There's two basic ways that elements bond. And that is ionic bonds, and that happens with electron transfer from a metal to a nonmetal, and covalent bonds, which happen when electrons are shared by two nonmetals. So if you're not sure how something is bonded, look for the metal. If it has a metal, it's going to be ionic. If it's all nonmetals, then it's going to be covalent. So an ion is an atom that has gained or lost one or more electrons. There's two types of ions. Cations, which are positive because they have lost one or more electrons and they have a plus. If it's a +1, we don't put the 1. If it's 2 or 3, then you put the number. And an anion, which has happened because an atom has gained one or more electrons and it has a negative charge. Ionic compounds form because electrons get transferred between the cation, so that it loses an electron, to the anion, which gains. So that's electron transfer. What holds ions together is the attraction that happens between opposite charged particles. So just like a magnet is attracted to the opposite pole, positive and negative particles are attracted to each other, and that's the basis for an ionic bond, this attraction. What makes a stronger bond, this is Coulomb's law, and we're not going to do the math for it, but you should be able to predict based on size and charge if it has a higher charge number. So +1 is higher than +2 and +3 is higher than +1. Sorry, +2 is higher, +3 is higher. Or if it has a smaller ion, so up higher on the periodic table are the smaller ions, then it's going to make a stronger ionic bond. So looking at these four bonds, this one up here, because it has 2s and it's small, is going to be the strongest. And this one down here, because the charges are lower numbers and they're bigger, is going to be the weakest. Strongest and weakest. And we would not compare these two because there's different things happening. So it's an overall trend. Small ions, higher numbers, stronger bond. So the actual ionic structure is not just two atoms together, but it makes a crystal structure that's a three-dimensional, we call it a three-dimensional lattice. So this is a two-dimensional version, so it's like a slice. Notice that each sodium is attracted to more than one chlorine, and each chlorine is attracted to more than one sodium. So it makes a three-dimensional structure that looks sort of like this for sodium chloride. They can definitely get a little bit more complicated when the ionic compounds are more complicated. Properties of ionic compounds. They are solids at room temperature, generally. They are usually soluble in water. That's not always true, but usually they are soluble in water. And they have very high melting points because there's so many strong bonds that to make them melt, you have to weaken all of those interactions. And that takes a lot of energy to do. So the melting point is very high. You can get them to melt, like with the Bunsen burner, but 400 to 500 degrees, very, very high temperatures. So this leads to the idea of electrical conductivity. In order for current to flow, you have to have electrons that are moving electrons. An electrolyte solution is a solution that contains soluble ions. So it is an ionic compound that has been dissolved in water. So now it has free ions that can move around. So here we've got three pictures, and which ones are going to conduct electricity? If they are dissolved in water, that's what this picture is. The blue are the water molecules. The green minuses, and the little gray pluses, those are the cations and the anions, and they are free to move around. So yes, when dissolved, they conduct electricity. Also, when they're melted, remember, it's hard to melt them, but you can melt them at really high temperatures. There's no water here, but because they're melted, the ions can move around. We call this molten salts, and these too conduct electricity. Notice the little arrows show that things are moving. So yes, melted, they can conduct. However, in the solid phase, notice that everything is rigid, everything makes a crystal structure, and things are not moving around. So electrons cannot move, and in the solid phase, it does not conduct electricity. So predicting ion charges, we are going to use the periodic table to predict ion charges, and you could tell by what group something is in. Atoms, again, gain and lose electrons so that they have the same number as a noble gas. So follow along with your periodic table. Group 1A is sodium, lithium, all of the alkali metals, and they have one valence electron, and we're going to show the one valence electron with the dot structures. One little dot means one outer electron. It's going to lose that one electron, and it's going to have a charge of +1, which means everything in group 1A is always going to have a charge of +1. So we can use the periodic table to predict the ion charge for the A groups. So group 2A, of which magnesium is in that group, alkaline earth metals, it has two outer electrons, two valence electrons. It's going to lose these two electrons and have a charge of +2. So following along in that trend, aluminum is group 3A. It's going to lose 3 electrons and have a charge of +3. But then something different happens. Then we go over to group 5A, which is where nitrogen is, and so we draw 5 dots. And now you could either lose 5 electrons, but that's too many electrons to move around. But nitrogen can gain 3 electrons so that it has 8, the same as a noble gas, and that will give it a charge of -3. So nitrogen makes an anion with a -3 charge. Oxygen, group 6A, 6 valence electrons. It's going to gain 2 to get 8 and have a charge of -2. Halogens, group 7A, like chlorine, they have 7 outer electrons, 7 valence electrons. They're going to gain 1 electron to get 8 and have a charge of -1. So in this list, go ahead and use your periodic table, stop the podcast, use your periodic table, predict the charges that are going to get formed from these elements, find them on the periodic table, figure out what group they're in, predict the ion, and then turn the video back on and check and see how you did. Okay, so hopefully you were able to find the elements in the periodic table, see what group they're in. Magnesium, group 2A, is going to lose 2 valence electrons and have a charge of +2. Sulfur, which is in the same group as oxygen, group 6A, is going to make a charge of -2, just like oxygen did. What about carbon and neon? These are not in my list, so what happens to them? Well, carbon has 4 outer electrons, 4 valence electrons, which we show here, and it does not gain or lose. What it does is it makes covalent bonds. Carbon is like the poster child for atoms that want to share electrons, and that's what carbon does. It doesn't make ions. You can force it to, but it really doesn't very often. It really is, it really pretty much always makes covalent bonds. What about neon? Neon already has 8. So that's why it's a noble gas. It does not want to gain or lose any electrons. It's happy just the way it is, and it doesn't make bonds.